Alright, we're going to do some reteach on each of the lessons from Module 7 other than graphing. So we're going to do substitution, elimination, and then we're going to do a day where we figure out which method's best, and then we're going to do a day where we talk about no solution, infinitely many. But let's start with today's lesson, which is substitution. The first problem I want you to be able to do, which hopefully will seem very easy, is if you ever have a system that looks like this, negative 3x plus 4y equals 20, and x equals negative 4. I hope that you realize this is a very easy substitution problem because you already have half your answer. They're giving it to you, which means we just have to go find the other half. And this is as simple as substitution is going to get. We're going to go make an x for x swap, but we now know that x is negative 4. So we go to the other equation. That's the key. Once you decide your substitution, you go to the other equation. Then you do the math. Negative 3 times negative 4 is actually 12. And then we are going to subtract 12. We now have 4y equals 8. So we can divide by 4 and get that y is 2. And the answer to this is negative 4, 2. That's our solution point where these two systems intersect. So that's one type of problem I'd like you to be able to do, the easy kind, when you got half the answer. All right, the second type slightly more difficult. All right, whenever you have a situation where they're not giving you half the answer, but they do have one variable already solved. In this case, we know what y is. Y is x minus 5. That allows us to go to the other equation, and where we were going to use y, we make that swap. And what do we know y equals? Well, this time we don't know the number that y equals, but we do know that y equals x minus 5. We do need to use parentheses because if you paid attention the first time when I taught 7-2, we're going to have to use the distributive property here. 3 times x is 3x. 3 times negative 5, we're going to treat that like negative 15. Combine some like terms here. We get 5x minus 15 equals 15. Remember, the goal here is we're trying to get one equation with one variable. So we started out with two equations that both had two variables. After substitution, we get down to one equation with one variable. The way you finish this one out is add 15. We now have 5x equals 30. Divide by 5, x is 6. Now that's only half your answer, because every one of these, if they have a solution that's a point, we got to find the x and the y. So come over here. The first equation said y equals x minus 5. I now know that x is 6. So 6 take away 5 is 1. And so the second kind of problem I need you to be able to do is, they didn't give you half the answer, but they did give you y already solved for, so you can plug it in the other equation and go. So we're working on substitution. So the answer number 2 was 6, 1. Number 3. This type of problem, Alex always likes to give you, and you don't need to let it bother you because it is pretty simple. If they give you both of them in y equals form, or even if they did both of them in x equals form, if two things are equal to the same thing, then they're equal to each other. So basically, you're taking the middleman out. If they both equal y, then they have to equal each other. And again, that takes you from two variables in two equations to just one variable and one equation. And then you just do the algebra you know how to do. Subtract 2x. We get 1x minus 1 equals -4. Add 1. We get 1x, also known as x, equals -3. That's half of our answer. So this time I'll use the second equation to do my backtrack substitution. I now know that x is -3. 2 times -3 is -6. -6 take away 4 is -10. So the answer to this particular system of equations, these two lines intersect at -3, -10. So notice today we're getting a unique solution every time. We're not getting infinitely many, we're not getting no solution. We're going to save that for another day, just trying to practice substitution. If they both equal y, then they have to equal each other. That's the third type of problem I need to be able to do. And the last one, this would be the toughest as far as what I'm expecting you to be able to do. This one is not going to look like it's ready to substitute at first. In fact, since we've already had the elimination lesson, some of you would be real tempted to eliminate, and that would be fine, that would work. But let's talk about how we could substitute here. I need to get a variable by itself. So y or this x would be very easy to get by itself. Doesn't matter which one you pick. But the reason they're easier is they have the coefficients of 1. So let me take those back off. So let's just say that you liked solving the first equation for y. Well, all you would have to do is subtract 5x from both sides. It would be gone, and that top equation is now y equals 7 minus 5x. And you can now go into the other equation. That's the key to substitution. You have to go in the other equation, follow the pattern, x minus 3, but we're not going to use y. We know that y is also known as 7 minus 5x. And again, the whole goal here is to get down to one equation with one variable. This does require the distributive property. We'd get 3 times 7, that's going to be a minus 21. Then we treat this as -3 and -5x, which would actually be plus 15x. All right, now I'd probably look for like terms. 16x minus 21 equals -21. I would add the 21 over. Now this is not a no solution situation. This is just saying 16x has to equal 0. You still divide by 16. Your x value is actually 0. Now, we know that x is 0. We know we've got half of our solution. We can go back to any of the original equations. For instance, x minus 3y equals -21. We could put in 0 in the place of x, which would basically kill that, and we'd be left with -3y equals -21. divide by -3, y equals 7, which means the other half of my answer, 0, 7, is the point where these two lines cross. So I'll put these 4 problems on Google Classroom, and you'll watch this video, and this is just a reinforced substitution before we do something with all of this. Test is going to look a little different this time around for Module 7. All right, we'll do elimination next.